This is video 2.1. It's looking at solving basic equations. Now remember that 2x plus 1 is an expression and 2x plus 1 equals 5 is an equation. Now this symbol here, the equal symbol, does not mean the answer is. It means that, or it's trying to show that the left hand side of this equation is identical to the right hand side of this equation. So if this side of the equation must be 5, we're trying to work out what the x is so that the left hand side of this equation is the same as the right hand side, which is 5. Now you can look at that and you can think immediately, well, I know that 2 2's are 4 and 4 plus 1 is 5, so x must equal 2. Now that is correct, and if you did that in an exam, then you would have solved that equation. You've worked out what the unknown must be on the left hand side to make the left hand side equal to the right hand side. Now remember, LHS is shorthand for left hand side and RHS is shorthand for right hand side of the equation. Now that's perfectly valid, and for some equations that you can use that to solve the problem. However, if I make the question slightly harder, like that, now it might take you a long while to find, and you may not ever find the value, exact value, that you can substitute into the left hand side for the x to make it the same as the right hand side. So in that case, it's not possible to do it in your head, so you do need methods that you can use to solve this type of problem. So don't fall back on thinking, well, I can always just guess the answer. Yeah, it's possible on some of the questions, but not on all of them. So you do need methods. And I'm going to show you a couple of methods in over the next few videos on how to solve these equations. Now, before we do that, let's just get something clear. A lot of the time you'll see equations written like that, 3x minus 1 equals 10. But I could have equally written the equation as 10 equals 3x minus 1. So don't be thrown by if you see a question that looks like this in the exam. It's exactly the same as the question as above. We've just turned the order around. So it doesn't matter if you put the equals, the 3x minus 1 equals 10 or 10 equals 3x minus 1. These two are the same. Now some students much prefer working this way, so if you get the question looking like this, you can always start off by writing it the other way round if you want, but be careful to write it down exactly the same way as you see it. Now I'll tend to write it down this way because that's just the way I'm used to doing it, and I'll use x a lot, but it can be any unknown. Okay, it can be 3a minus 1 equals 10, or it could be 3b minus 1 equals 10. It doesn't have to be x for it to be an equation. There are a few letters that we do avoid for obvious reasons. You shouldn't see the O being used because it looks like 0, and L because it can look like 1. But there are some other letters that are avoided, and you'll find out why if you do more advanced mathematics. So this video is aimed for both higher and foundation students. And before we move into the key part of it, I just want you to think about opposites or inverses. And what I've got here are 4 operations: multiply, divide, add and subtract. And what I'd like you to do in a second is pause the video and write down on the other side of the arrow the opposite to multiplying, or the inverse of multiplying. So what is the opposite thing to multiplying? Okay, now pause the video, and when you've written down the 4 answers, then start the video again. Okay, well, the opposite to multiplying, hopefully you've written down dividing, so the inverse of multiplying is dividing, so the inverse of dividing is multiplying. The inverse of adding, or the opposite to adding, is taking away or subtracting, so the inverse of subtracting is adding. Now that's a very important concept which we'll come on to use a lot in both methods that I'll be showing you over the next few videos. So don't forget that. It's very important. And that's something you've known for quite a while now, hopefully. Okay, well let's just jump straight into a nice straightforward first equation then. So what I'd like you to do, now you should know the answer to this question when I wrote it down, but what I'd like you to do is to work along with me. Don't just watch the video. You don't learn mathematics by watching it, you have to do mathematics to learn mathematics. So I'd like you to work along with me. So we're going to start with a nice easy equation. X plus 2 is equal to 6. Now, you don't get any prizes for knowing the answer to that one, I'm afraid. Hopefully you can all see that one immediately and know the answer to that one immediately. Okay, but great if you have done. You can write, if in an exam and you saw that question, you could write down the answer straight away. So I know you're all telling me immediately, come on, that's too easy, that's x equals 4. Now we're going to use some easy examples just to explain the two methods that we're going to use. Now method 1, I'm going to call it method 1, and method 2. Now you choose which method you prefer longer term, but what I'd like to say is that higher students should really understand the method 1, because when we come on to solve simultaneous equations later on, or when we come on to solve simultaneous, certainly with linear and quadratics, you will definitely need to know method 1. It also helps when we're rearranging formulae later on, whereas foundation students, you can use method 2, and so can higher students, but I would recommend that the higher students get their head around method 1. So what we're going to start off with is by writing x plus 2 equals 6, and we're going to look at method 1 first. So we've got an x plus a 2 is equal to 6. So what we want to know is what x is on its own, because if we can get x on its own on this side and then a number on that side, or even an expression later on, then we've got the answer to what x is. We know what x is equal to, because x is on the left hand side will be equal to whatever's on the right hand side. So we just want x on its own here. Now we've got an x plus 2 here, so we've got to do the opposite to adding 2 to the x. We've got to take that plus 2 from both sides. We've got to get rid of that plus 2. Now to get rid of it, add 2, we take away 2. Now I'm writing it underneath here. Sometimes you're taught to write it at the side there. Some students won't write any method at all, they'll just write the work. They'll work it out, and certainly when you get towards A level you certainly won't need to be writing your method steps like I am here, but I'm just showing you what I'm doing by writing underneath or writing it to the side. Now if I take 2 off this side, then this balance is no longer equal. So whatever I do to this side of the equation, I must also do to the right hand side of the equation. So I take 2 from the right hand side. So what I've done is I've taken 2 off the left hand side and I've taken 2 off the right hand side. Taking 2 off the left hand side leaves x on its own, and taking 2 off the right hand side gives me 4, which is the answer that we all know we were looking for. So that's a nice basic straightforward example of using solving equations. Now this method, method 2, some students prefer, is called the inverse function machine, and I'm going to show you both methods here, and then I'm going to record from then onwards. For the first few videos I'm going to record a video for method 1 and then a separate video for method 2, depending on which one you prefer, but just this first video you need to know which the two methods are so you understand the later videos. So on this one we write down the equation again, x plus 2 equals 6, and then we say to ourselves, okay, well what happens to the x? Well the x, what happens to it is that we add 2 to the x, because we have x add 2, and that's the only thing that happens to the x. And if we start with an x and we add 2, and we get 6 out, because that's what happens. That's the left hand side is the same or equal to the right hand side, which is 6. Now this is the key part about an inverse function machine. What we do basically is we turn the machine backwards, and everywhere that we had a operation this direction, we do the inverse thing in this direction. We do the opposite. So instead of adding 2, we take away 2. So 6 take away 2 is 4. So x is equal to 4. We must always write that down underneath. So that's called the inverse function machine. Now a lot of students much prefer this method, which is why I'm going to show you this method, but I'm also going to show you videos on this method. So this video basically was to introduce the basics of equations and also to show you the two types of video methods that I'm going to suggest you use. Okay, so if you go to the next video, it will be dedicated to this type, and it will be called solving equations. And this, if you go to the third video or the fourth video in the series, it will be dedicated to this type, which I'll add inverse function machines. Okay, so it'll be by solving equations using inverse function machines. Inverse function machines. So look out for that if that you are looking to use this particular method.